Okay, let's be familiar on adsorption isotherm. So, for all of this, along this Langmuir Hinshelwood kinetic mechanism, you'll be always seeing this symbol of S. So it's for active site. A is for reactant, um, especially reactant, which is whether it is in atom, molecule, or atomic combination. A dot S, meaning that the elements of that reactant, which is species A, will be adsorbed on site S, on this active site. Okay. The CT here, meaning total molar concentration of active sites per unit mass of catalyst. CV can be defined as molar concentration of vacant sites. PR is partial pressure of species in gas phase. Species, whether it's going to be here species A, B, C, or maybe it will say carbon monoxide, carbon dioxide. Okay, but P is for partial pressure. C I dot S means the surface concentrations which the sites has been occupied by species. So I represent a species, maybe A, B, C, or carbon monoxide, CO2, or H2O, or any other kinds of fluid, which is in liquid or gas. Okay, so kita ambil contoh, for example, reactant A berjumpa an active site, the vacant one. So of course, this A is going to adsorb on these active sites, and so terhasillah A to be adsorbed, already occupied on the vacant site. So kita tengok term kat sini, S is active site, A is the atom or molecule or atomic combination. A dot S means one unit of species A adsorbed on site S. P is partial pressure of species. So, for example, here we have this active sites which is vacant, and this is A. A is about to close to these active sites, and it's going to be attracted, and the A is occupying these active sites here. So kalau kita nak buat site balance on concentration, so total concentration untuk this occurrence adalah concentration of vacant sites plus concentration where sites has been occupied. Okay, that's the theory. Previous slide was the case for maybe single reactant. So let's have a look at this two reactants, A and B. So let's say A jumpa satu vacant site, so dia akan try to adsorb here. B jumpa juga satu vacant site, and it's adsorbed on this vacant site. So jadi site balance-nya, the total concentration would be the concentration of vacant sites plus concentration of sites being occupied by A, and concentration of sites being occupied by B. So again, ini is the definition of the term. CT is total molar concentration, CV molar concentration of vacant sites, CIS is the surface concentration of sites that occupied by species. Okay, adsorption isotherm. So isotherms can be defined as the amount of gas adsorbed on a solid at different pressures but at one temperature. Jadi kenapa kita belajar semua Langmuir Hinshelwood ni? The kinetic model, this one is just a theory in which that kita propose the model. So bila kita propose the model in which katalah adsorption happens, surface reaction happens, desorption semua tu. Lepas tu kita compare dengan experimental data. So bila kita compare the proposed model with the experimental data, we are going to look which experimental data that is close adalah dekat dengan model. Jadi kita akan kata that model, what's happening in real situation is apa yang berlaku lah pada experimental data tersebut. Okay, adsorption pula. Sebelum ni kita guna simbol A, B macam tu saja kan. So let's say kita guna the real one. For example, we have carbon monoxide to be adsorbed on a surface, a vacant surface. Tapi kita boleh secara teori kita boleh katakan di carbon monoxide ni dia adalah molekul. So it can be non-dissociative adsorption ataupun dissociative adsorption, meaning that kalau non-dissociative, carbon monoxide as molecule dia akan adsorbed on active sites as molecule dan jadi carbon monoxide as molecule adsorbed on active sites. Tapi kalau dissociative bermakna C dan A ni dia akan dissociate. Bila dia dissociate, dan dia akan adsorb on different active sites. So bermakna C dia akan adsorb on one active site, O akan adsorbed on one active site. Okay, based on this reaction of adsorption proses ni, kita boleh kata dia berkemungkinan equilibrium. Reversible. So bermakna akan terjadi bermula adsorption, which is attachment of carbon monoxide kepada vacant site. Lepas tu berkemungkinan akan jadi juga dia berbalik detachment, which is carbon monoxide adsorb on vacant site ni dia akan terjadi balik kepada carbon monoxide and vacant site. So kalau kita nak cari rate of attachment, kita nak cari rate of adsorption, it has to be the rate of attachment plus the rate of detachment. So bermakna kalau you ingat lagi last semester punya course and on how to find the rate of reaction, so kita boleh adopt in this course. So rate of attachment ni kita adopt dengan last time yang kita belajar. Jadi nak cari rate the forward one, attachment, which is CO plus S, terjadinya CO dot S, that is attachment. So rate of attachment is katalah ini rate constant Ka, dan kita mengambil disebabkan carbon monoxide is gas, so kita ambil partial pressure instead of concentration. So rate constant of attachment times partial pressure of carbon monoxide times times this one S, concentration of vacant. Kalau detachment pula, which is dia punya equationnya adalah CO.S. CO.S terurai menjadi CO plus S kan. Dan katalah dia punya rate constant is K or space A. Ini menunjukkan detachment. So, kita boleh tulis the rate of detachment is the rate constant space A darab concentration of sites being occupied by carbon monoxide. In which adsorption equilibrium kita pernah belajar juga rate, kalau dulu rate for constant forward divide by reverse. So yang ini Ka attachment divide by detachment. Okay. Jadi kalau you nak cari rate of net rate of adsorption, so yang ini adalah rate untuk attachment, yang ini adalah rate untuk detachment. Okay, untuk slide yang previous, saya terangkan berkenaan how to find the rate of adsorption for non-dissociative. Jadi kalau you perasan ada dissociative, dibuat tanda soal kan. So kalau boleh, I nak you cari sendiri macam mana dapatkan rate adsorption for dissociative. Okay, untuk slide ni, what are the assumptions that we can make for adsorption mechanism? So it depends on the surface. The equation can be considered as elementary in order to determine the rate of adsorption. So kita akan assume there is rate of attachment and also the rate of detachment. Kemudian, in order to find the net rate of adsorption, meaning that the rate of attachment to the surface minus the rate of detachment from the surface. So that's the theory of adsorption mechanism. To obtain the Langmuir isotherm, we have to consider the surface of catalyst and also the adsorption system.